Hello friends, how are you? So today we'll be revising the topic arrays. If you are a working professional or if you are a student also and you don't have the confidence that you know all the concepts of array or not, so you can see this video. And in this video I have not discussed sliding window and all because that's a technique basically, and I have told that in some other video. Okay, in this video we will see some of the uh, good questions, good problem solving skills. Okay, so what is an array? As you know, it's like uh, it's like ordered set of homogeneous data types. Okay, if you are assigning a string, then in the array all the elements will be string only, and it is continuous memory location. It means if one first element is an a zero some address, if some address 1000 first element, then the second element will be on the address 1004, or the third element will be in the address 1008, as it will contain 4 bytes. Okay, I think it will contain 4 bytes, 1 2 3 4, then 1005 will be the address of it, then accordingly. Okay, so you can say that if we are declaring an array of 5 length, then that means each element will take 4 bytes and it will take the 20 bytes memory. Advantage is we can randomly access any of the element. If you want to access a fourth element, then just we have to write array of fourth element. Okay, okay. What is there are few terms associated with the array, that is subarray, subset and subsequence. Okay, subarray is what? Continuous part of the array. If this is subarray and this is another subarray, this is another subarray. Okay, what is a subset? Set of some element, but order is not important. Okay, it means like if this is an array, then uh, 11 14 or any of the element that belongs to this array can be called as the subset of the array. Okay, then third term is subsequence. Subsequence is set of some element of array, but order is same as the original array. You have seen the famous problem LIS, longest increasing subsequence, LCS, longest common subsequence. Okay, if there's two string, we need to find the common subsequence. Okay, suppose cat and mat, the common subsequence is 80 of length 2. Okay, so this is called subsequence. Subsequence means order matters. So 11 then 3 then 6, it is not a subsequence, but 11 then 6 then -1 then 9 then 14, it have a same order as of the original array, so it is a subsequence. Okay, so relax for a bit, as you have filled yourself with so much information, I think. So now we will discuss some problem solving. Okay, I will give you a problem, you need to think about it and tell me the solution. Okay, so I have written few problems that you can see in my screen. Okay, first problem is reverse the array in O of 1 extra space. So let's discuss this. So this is the array 3 4 5 6. Okay, and you need to reverse the array. So what you will do, you can easily sort the array, and then you just need to reverse the array. Order, don't know, like order is anything, you just need to reverse it, like 1 7 8 2. Okay, so this you can do easily. What are the first solution you're thinking how to reverse it? You need to basically swap these two indices, then these two indices, then these two indices. So okay, so basically you can put your one pointer here. Pointer means just a variable holding the index. okay, and just you can do while I minus j, like there is no use of swapping with 4, okay, and swap the index of a of I and a of j, and just pi plus plus and j plus plus, so that contains no space, order of one solution. Okay, so I think this was basically so much easy. This was just a warm up to think like how you can do this problem. You can see the time complexity will be easily O of n by 2, I think. Okay, sorry. So now let's move to the second question, that is rotate the array k times. Okay, so let's do this question. Like rotate the array means if the array is 2, 4, 5, 6, 1, 8, 9, if k is 2, okay, then these two elements will be come in front, okay, like line 8, and all will be shifted. This, okay, this is the famous interview question. Everyone asks this. This is so easy also. The intuition behind is here. If you talk about the intuition, it will be that you want to basically make you want these elements to come in front. Okay, this you want, but what you want here, it is 8, 9, then in the answer array it is 9, 8. So you got the intuition that somehow we need to reverse it. Okay, so the solution may be to reverse the whole array. Let's reverse it. 9, 8, 1, 6, 5, 4, 2. Okay, and then k is 2, so what you need to do is reverse the first two elements, 8, 9. Okay, and then just wait, and just reverse these all, 2, 4, 5, 6, 1. Okay, so I think rotating means 9 come in first. Sorry, my bad. The answer will be this only. Okay, I think you got the intuition. The intuition was just to reverse the array, as you want last element in front, and then you want correct position, then reverse the k elements, and then reverse the uh, rest of the elements. Okay, reverse the k elements and then reverse the n minus k elements. Okay, fine. So that is easy. You can also do like this way. For 2, 4, this is the array, reverse the first two elements. Okay, sorry, yeah, firstly you reverse the first two element, then you reverse all other elements like 9, 8, 1, 6, 5, and then you can reverse the whole array. Oh, that is not working. I don't think that it should not work. Somebody told me that it will also work. Okay, so if we will reverse whole array, it will also not work. Okay, that's a bad idea, I think. So the algorithm is very simple. Okay, like algorithm is, firstly reverse the whole array 0 to n minus 1, then reverse the first k elements, then reverse the left out elements. Okay, so in this way you can achieve your answer very easily. And if you are thinking about the intuition, then I told you that you want these element in first, okay, and these element in last. So firstly you reverse whole array, and then to maintain the correct order you need to reverse first k element and last k elements. Okay, so I think it is clear. let's move to the third question. And I don't think there's a use of writing code, I think, because that is quite easy. You can implement it, although you don't want to mug up the code for sure, right? So the third question is Q queries. Oh, sorry, my bad. There is no undo button, I think. Undo. Okay, there is. Okay, so Q queries find the sum from L to R. Okay, so this is a famous technique of cumulative frequency or prefix sum, whatever you say. Like, okay, for example, you have a given array, okay, -6 3 2 4 5 -2 1 9, and just want this sum L to R, okay, and there are Q queries. Every time L and R can differ, okay. So what you can do is like maintain a prefix sum array. Prefix sum like cumulative sum. Sum till here is 3, okay, sum till here is 5, sum till here is 9, then sum till here is 14, sum till here is -12, sorry, 14 minus 2 is 12, sum till here is 11, sum till here is 20, I think, okay. Then L to R index, you want to sum, okay. So what you can do is this is the subarray. Up till here you know the sum, that is 12. You can subtract it with this sum, that is 3. 12 minus 3 is what? 9. Okay, then you can see 5, 9, 10, 11, then -2, 9 only. Okay, so the simple formula is prefix of R minus prefix of L minus 1 is the required sum. Okay, this technique is very famous. When I was in BTech third year, maybe, or maybe second year, I got to know about this, and I was little bit like thinking that this is quite new, but when you proceed with the coding, this is quite basic. This prefix sum, okay, this can be anything. This can be prefix of any data you want to maintain, okay. Okay, so let's move to the fourth question, I guess. I don't want to make this video long because I don't want that everybody should stuck, in anything. So find the equilibrium index of the array. So this is only the modification of that question only, nothing else. So you need to find the equilibrium and index, like such that sum of left elements should be equal to the sum of right elements, okay, and this index is called the equilibrium index. So if you see, it is quite easy. Let's assume this is I. So you want 0 to I minus 1, sum should be equal to I plus 1 to n minus 1. So you know how to find sum between these. Prefix of I minus 1 minus prefix of, actually if it is 0 you need to minus nothing, okay. So this will be like this only, should be equal to prefix of n minus 1 minus prefix of I, okay. You will run a loop from to the whole array and see if this condition follows, then return that equilibrium index, okay. That was so easy, like based on the previous question only, nothing so special about it. Now we will discuss some good question, I think. The fifth question is sum of all subarrays of an array. Like we need to find the sum of all the subarrays, okay. So let's take a very small array, 865, okay. Then what are the subarrays of these? 8 6 5, okay. Then then 8 6, then 6 5, then 8 6 5. It's like 3 elements, so the number of sub-arrays is 1 2 3 4 5 6. Okay, because this can appear in a sub-array or not appear, appear or not appear, appear or not appear. So every element has 2 possibilities. Okay, so I think is 3 factorial. Okay, 2 into 3, that's 6. Okay, why it is 3 factorial? If you see, because okay, I'll explain sometime later. So this sum is 8 6 5, this sum is 8 plus 6 14, this is 11, this is 19, and if you do this sum, this will got 63. So you need to find this. So the brute force is very simple, just n square solution. You will run a for loop from L, that is 0 to n. You will run another for loop that will run from L to n, and you will find the L to R sum. Okay, and you will add that into your answer. Or you can also provide third loop from L to R, and this will sum up. Or you can directly optimize it, find the prefix sum before, and find L to R sum very easily. Okay, so this is n square solution. Basically what you are doing is holding here, then extending it L to R, L to R, L to L, then moving here, then this all sub-arrays you are trying, then moving here, then not trying all sub-arrays. Okay, so with this approach you can also think of the carry forward technique. What is this carry forward means? It's very simple, like you are carry forwarding your answer, although you need to find all the sub-arrays somewhere, right? So what you can do is, you have the array 8 6 5. Okay, you can take 8. Okay, it will be included in your sum. The next sub-array is 8 6, 8 plus 6. Okay, that will be included in your answer. Okay, the next sub-array is 8 plus 6 plus 5, that will be included in your answer, that is 19. Okay, plus now you will move your this L pointer. Now this is 6 is a valid sub-array, you will plus 6. Okay, then you will 6 5 is the valid sub-array, then you will plus 11, then you will move your L pointer when your array got finished, and then 5 is a valid sub-array, you will add 5 and you will get 63 at the last. Okay, so what is you are doing is not adding again and again, but carry forwarding the sum. Okay, so with code maybe you can understand better, like just a follow. We are taking sum as itna, then you are moving or starting with here, taking this as a sum, taking this as a sum, taking this as a sum, taking this as a sum. Okay, but you are carry forwarding the sum also, and R is also increasing. Okay, so you will write like this, and you will sum it with carry forward technique. Okay, and every time it is a valid sub-array, so you will plus in your answer. Okay, you got the question, huh? You need to find the sum of all the sub-arrays. Okay, I think you got the question well. So this is called carry forward technique. Okay, the fourth technique is combination technique. Okay, what this combination technique is? sorry, not combination, it's contribution. Contribution means what is the contribution of each element to your answer. Answer was 63. What was the contribution? Like if you see all the sub-arrays, 8 is contributing how many times? 1, 2, 2 times. 6 is contributing 1, 2, 3, 3 times. Plus 5 is contributing 1, 2, 3, 4, 4 times. Okay, and if you add these, so 20 plus 16 will give 36. 36 plus 18, 8, 9, 10, 11, 12, 13, 3, 4, 5, 53. No, I think something I have done wrong. Okay, sorry, this will be 8, 6. 5, 6 we have already counted here, so this will be 8, 6. 8, 6. Okay, so here 8 is coming 3 times, so it will be 24. Okay, now I will see it will come to 63 only. Whatever the answer is, it will come that only. You can see your calculation. Okay. Okay, so idea is we need to find the contribution of each element and see. Okay, so we need to find it, the contribution of each element. How to find the contribution of each element actually? That is the question. So you can think you want to find the contribution of this ith element in this array. Okay, 0, 2 and minus 1. So what you are saying, this ith element can appear in every sub-array occurring in this side. Okay, this side, and ith element can also occur in every sub-array occurring in this side. Okay, so number of sub-array from 0 to I is, what will be the number of sub-array from 0 to I is, like I told you, it is I plus 1. How? That if you want to find the elements between 11 and 16, it will be 16 minus 11 plus 1, that is 6 element. Okay, so if you want to find the index, how many elements between 7th and 11th index, then you can find 7 minus 11 plus 1. Okay, and you will find the length of the subarray, or you can say number of elements between two indexes. Okay, so how many elements it will contain? Now you can see easily, n minus 1 minus I plus 1, that is equivalent to n minus I. Okay, so what will be the contribution of ith element? Ith element contribution is I plus 1. This all element can be taken as a starting point and here as ending point. Okay, how many combination it can make? You can find the product. Okay, these many subarray ith element will be the part of, like some index will be starting here, ending here, starting here, ending here, starting here, ending here. Okay, so starting here, ending at all the index, starting here, ending at all the index. So you can say it is a property of product, so we are taking product. So it's now it's very easy. You just need to run a loop from 0 to n minus 1 and just multiplying each element with its contribution. It means that many time it occurred and it will be contribute to that answer, means sum. Okay, so it is order of n solution, although you need to see every element to find the sum, so it is okay. I think now you are getting bored with this. Okay, I think now the time will be also so much. You must be getting bored. But please hold on. There are few only very less amount of questions left. Only I think 2 questions is left. Um, the okay, there are 4 questions left. So the next question is maximum absolute difference. Okay, let's understand the question first. Okay, I got the question. Can I copy this line? I don't know. Okay, sorry. Firstly, erase these all things. Okay. This is the best feature. What I can do, I think. Copy. Can we paste here? How to paste it? Actually, I don't know how to paste it. Let's forget this. Okay. We can write it all down. So the question was given an array, given an I am tired really. Thinking of finishing this video in second video. You need to find 2 index. This is the question, and that was asked in Codegon of interview bit. Okay, and it was not considered as tough but medium question. Okay. It is recording. I think it is. Sorry, but I am thinking of proceeding on this question and other one in the next video, or rain dropping problem in this question. All the best. Thank you for seeing this